tutorial, I'm going to go over exam number 5, which is on Galileo and his 4 ideas. Idea number 1, heavy and lighter object fall at the same rate, touch the ground at the same time. In equation, you can say t is equal to square root of 2d over g. G is the acceleration due to gravity. The second idea, distance of a falling object, right, increases quadratically. You can say d is equal to half at squared. Velocity of a falling body, or you can say speed of a falling body, right? Speed of a falling body increases linearly, right? And you can say Vf is equal to Va plus At, and acceleration of a falling body remain constant, and you can say acceleration is 2d over t squared. So many students came today, 8, 9, 10 period, like at least 50 students come today to do the experiments, Galileo's experiments. Aristotle 2 ideas, velocity is proportional to weight, and velocity is also proportional to what? 1 over density. So many students did the experiment today here in the class. What does that mean? That means we are expecting wonderful presentation on November 8. The group leader will be uploading them to the Google Classroom, and November 9 we're going to show it to the class, right? This is going to be the most important assignment of MP1, so make sure you spend your weekend to make it as perfect as possible. Keep it less than 4 minutes. Okay, good. Now we are ready to dive in exam number 5. Car, right? Car number 1, which you call DA, right? And dA would be d initial plus VIT, right? Plus half at squared, but you don't have to write that because you know it is a constant velocity. Di is 0, d initial is 0. And let's see the green car. The green car has, we're going to call it dB, right? dB is di plus VIT plus half at squared. Again, at squared is 0 because acceleration is 0. However, the green car has a head start, right? Head start meaning that di for this one is 200. Now at some point they're going to meet. The green will meet this blue will meet with the green over here, right? Over here, right? Okay, one thing we know that blue move faster. Blue move faster, 20 meters per second, and the green moves slower. Green moves 15 meters per second. 15 meters per second. Okay, all right. So eventually, the blue will ahead, but at only one time they're going to meet, right? So in order to catch up. So it says how far must B travel from this initial position, right? The B's initial position is this, to catch up with car A. So the car A is already here, right? And the car A to be over there, car A has to move 800 meters, right? And the car B has to move only 600 meters, right? Only 600 meters, because 600 plus 200 is 800. So let's do the math and let's see how that how did I get that. Okay, so I'm going to put this equation over here and I'm going to call it dA, and I'm going to put this equation and I'm going to call dB, right? Okay, good. So di is 0 and di is 200, vi is 20 and vi is 15. So what I have over here, I have dA is equal to 20t and dV is equal to 15t plus 200, right? So I can say over here, right here, dA is equal to dV, right? If I do say that, I can say dA is 20, right? 20t is equal to 15t plus 200, right? So that I have 5t is equal to 200. So t is equal to 40, right? Okay, 40. Okay, good. Now, so 15 times, this moves how fast? This moves 15 meters per second. This moves 15 meters per second. Now, how much this can go? dA can go in 40 seconds. dA can go 800 meters. So this is 800 meter from where? 800 meter from there, right here, right? The dA, in order to be here, dA has to move 15 times 40. 15 times 40 is 600. So this is how you can do this problem. Okay, good. Now next problem, let's say I am gonna ball 2, as you see that horizontal means Vx, so we're gonna totally ignore that. We don't need that information. The ball falls 4 seconds, right? We want to know the building, how tall is the building. If ball fall 4 seconds, how tall is the building? That's the story here. So if the ball falls 4 seconds, right? If the ball falls 4 seconds, then how tall is the building? Very simple. So d is equal to half at squared. So d is equal to half. You have negative 9.8, or just absolute value. Use absolute value, but let's use negative 10 because we don't want to use a calculator. Half negative 10 and 4 square, right? So you have d is equal to half negative 10 and then 16, right? 2 goes to 16, 8. So d is equal to negative 80. What meter? Take the absolute value. D is equal to 80 meter, because height. We are looking answer in terms of scalar quantity. Also notice that if we did use 9.8, we would have gotten 78.1 or something. So but if you do use calculator, always use 9.8. If you use the mental math, you use negative 10. And then let's look for it. Which one is close to 80? Is this close to 80? No, this is not close to 80. This is not close to 80. This is not close to 80. This is close to 80, so this is the right answer. That takes us problem number 3. Problem number 3, I ask you what would be the acceleration at 8 seconds, right? Yeah. So, oh no, how many times entire motion experience maximum? No, what did I ask you for this one? This one I ask you, find the acceleration of the object at 8 seconds. At the 8 second, what is the acceleration? Well, it's pretty simple, negative 4. But if you don't see it, why negative 4? Then what I want you to do, this is displacement versus time. You have to convert it to velocity versus time graph. And that will make it obvious. This is velocity versus time. And maybe you want to convert it to acceleration versus time. But let's make it super obvious. So now, let's first make the slope of this one. The slope of this one is 2. Let's make the slope of this one. The slope of this one is 0. Okay, good. Let's make the slope of this one. Slope of this one. Slope of this one. Okay, slope was max over here, right? Max over here and 0 over here. So 0 over here, max over here. So max over here and 0 over here, right? Okay, good. So max, and from max to 0, right? Max to 0. Very nice. Okay, I'm gonna erase this t. T has to be here. Okay. Now from here, what about from here to here? From here to here, you start from 0 and the max is speed. Max is speed. So from 0 to max is speed, right? Okay, good. So I have this. You probably don't need it, but let's say you just do. And this. Okay. I want to find a max speed. Okay, I want to find max speed. Okay, max speed is here and max speed is here. All right, max speed is here and max speed is here. So, okay, what I know about the blue? I know about the blue, the area of the blue is half BH, right? Okay, area called VT graph. So area has a name, right? Area has a name. Area is displacement. So we're going to call it displacement is equal to half. B has a name, T. And H has a name, velocity, right? So displacement, we know that displacement from 6 to 8. displacement from 6 to 8, 6 to 8 is 16 minus 8, which is 8. So displacement is 8. Half t is 8 minus 6 is 2, and then velocity. So velocity is 8, or speed is 8. Okay, and this velocity has to be negative 8, but we are looking for speed, right? So that speed has to be 8, right? Velocity is negative 8. So I want you to take the absolute value. Why? Because I'm asking you to find, what did I ask you? Find the acceleration of the object at 8 seconds. No, we are not done yet. So we're going to try to find the acceleration at 8 seconds, right? So now acceleration versus time graph, we're going to have to take the slope of this. So now take the slope of this. Slope of this is, oh no, take the slope of this. Slope of this is 0. Take the slope of this. Slope of this is 0. Take the slope of this. Maybe I'm going to use the blue. Slope of this. Slope of this. This is slope of this is negative. Whatever it is negative. So negative. So we can find the slope of this one, right? Between 6 to 10 is a constant acceleration. So if between 6 to 10 is constant acceleration, then at 6 seconds, the acceleration would be as same as at 8 seconds or 10 seconds. So let's find the acceleration. Acceleration is Vf minus Vi and Tf minus Ti. So Vf would be what? This is Vf, this is negative 8, minus Vi would be 8. Tf would be what? 8, or maybe, I don't know, maybe 10. 10 minus 6. So 10 minus 6 is 4, right? 10 minus 6. Okay, good. So then you have negative 16 over 4, which is negative 4. Okay, negative 4. So acceleration is negative 4. So what is the acceleration over here? Acceleration over here, negative 4, 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 negative 4. Acceleration at every single moment between 6 to 10 seconds is negative 4 for this reason. So the answer is, of course, negative 4. Okay, that takes us problem number 4. Quickly, you're going to go to problem number 4. Problem 4, how many times the entire motion experience maximum speed? Well, 2 times, right? 2 times. So if we do it again, I don't know why I need to do it again, but let's do, let's say we want to do it again. Vt and At. How maximum? We don't have to do At. So it's just Vt. Okay. So if we do Vt again, I can do it in slow motion, Vt. So this one is 2, right? This one is 2. We can make it longer since we're not going to have to do the At. This one is 0. This one is 0. This one is whatever it is, maximum velocity to 0 velocity to 0 velocity, good. And 0 velocity to maximum speed. Again, 0 velocity to maximum speed, 0 velocity to maximum speed. But we can, we don't want to graph it this way. Why not? Well, it's because this, we want to take the absolute value of this one. If we do take absolute value of this one, and then we will get, okay, so this would be, as I showed before, this would be what? This would be velocity. This would be negative velocity. We can take the absolute value of this one, negative velocity, right? Okay, good. Now, this will give you this velocity, and this will give you this velocity. This velocity is, again, I don't want to, should I do it again? This is area is equal to half BH. So area has a name, displacement, half, B has a name, T, and H has a name, velocity. Displacement from, okay, from 6 to 8 is, from 6 to 8, displacement is 16 minus 8, which is 8. Half, the 8 minus 6 is 2. So this is 8. So this is must be negative 8. Absolute value of 8 is 8. Absolute value of negative 8 is also 8. So how many times velocity speed, maximum speed? 2 times. 2 times object has a maximum speed. This time is 8, and this time also 8. 2 times object has maximum speed. Okay, good. That takes us problem number 5. All right, problem number 5. I ask you find the object acceleration at 4 seconds. 4 seconds. To find the acceleration in 4 seconds, you can find the acceleration from here to here. Why is that? Because this has a negative slope, right? So if you find, or maybe you can find the entire line, doesn't really matter. So that means slope between what? Slope between you have 3 second to 7 second. Okay, so what do you know about acceleration? Acceleration is Vf minus Vi and Tf minus Ti, right? So acceleration is Vf. What is Vf? Vf is here, right here, negative 20. And Vi is positive 20. Tf is 7 minus 3. So you have acceleration is negative 40 over 4. So acceleration is negative 10. Okay, good. That takes us problem number 6. That takes us to problem number 6. Problem number 6. A basketball player moves 20. So this is a basketball player, right? And this is 20 meter. 20 meter from here to here, right? 20 meter. So he moves back and forth. How long? 3 times. So he moves back and forth 3 times. So he is here. So like this, he goes here and come here. So 20 times 3, which is 20 times 2, back and forth, forward, backward. 20 plus 20, which is 40. And he does it 3 times. 1, 2, 3. And that takes, to do it 3 times, it takes 60 seconds. So is 2 meters per second. All right. So that's average speed. His average speed is 2 meters per second. That takes us problem number 7. And problem 7 would be kilogram thrown. Mass doesn't really matter. Galileo said mass doesn't matter. You throw an object vertically, right, upward with an initial velocity 9.8. What is the maximum height? In order to find the maximum height, you always use Bf square is equal to Vi square plus 2AD, right? And when you throw up something, right, at the max height, when velocity is 0, right, you have the max height by definition, okay? If it is a DT graph. At the max height, velocity is always 0. At the max height, the velocity is always 0. So Vi is 9.80 square, right, minus 19.6 D. So D is 9.80 square, which is 10, which is 100. This is also 20, right? So 0, 0 cancel. So D is this, let me see, Vf square, Vi square, which is 9.80 square. This is, yeah, so where is my calculator? 9.80 square, 9.80 square divided by 19.6, and that is 4.9. So the answer is 4.9. Okay, good. So the answer is 4.9. Okay, so 4.9 D is equal to 4.9. Maximum height is 4.9. Okay, good. That takes us problem number 8. A child riding a bike at 15 meters per second, right? So this is your initial velocity, right? And this is your acceleration. Don't forget that. And he does it for 4 seconds, right? 4 seconds. And this is your t, right? What do you need to find? What is the child's speed at the end of, okay? So remember, Vf is equal to Vi plus At. Never forget this equation. So Vf is equal to Vi is 15 minus 3, 4. So Vf is equal to 15 minus 12, which is 3. So 3 meters per second. And that takes us to problem number 9. Okay. And And observer, okay, so this is the, they already told you constant acceleration. So you can use this 2 point or this 2 point, this 2 point. Okay, let's use the rate first. Acceleration is Vf minus Vi Tf minus Ti. Okay, so acceleration is Vf is 7 minus 4, 5 minus 3. So you have 3 over 2. So acceleration is 1.5. Let's do the green. Acceleration is Vf minus Vi Tf minus Ti, right? So acceleration is Bf is 8.5 minus 7 and 6 minus 5. So acceleration is 1.5, right? Okay, so no matter how you do it, you get the same acceleration, and which is 1.5. Okay, good. I'm sure 1.5 is in the answer choice, but that takes us to problem number 10. Okay, so a marble is just from rest and accelerate. So a marble is just from rest, right? So this is a marble. This is a marble. So a marble, this is 1D. I cannot roll this marble, but if I drop this marble over here, so it's going to roll this direction, right? With acceleration 0.15 meter per second square to speed up 2.4 meter per second in 20 seconds on the ramp. This motion could best describe as acceleration never increase. Acceleration is always constant, right? Constant acceleration, that's good. But that's good, constant acceleration, yes. But constant velocity, no, not constant velocity. If acceleration is constant, velocity cannot be constant. So constant acceleration causes increasing velocity. So it's C. Okay. Constant acceleration always cause constant acceleration. Galileo's theory is constant acceleration causes what? Constant acceleration causes linear increase in velocity and quadratic increase in distance. Okay, good. That takes us problem number 11. Problem 11 is whose graph represent relationship between the speed of freely falling object, so object fall freely on the earth's surface. So when object fall freely, what happens? You can get three things, right? dt, vt, they are doing distance, where speed time, and acceleration versus time. So the dt will look like, dt has to look like this, speed has to look like this, acceleration has to look like this. Okay, so now our speed, this is wrong, a is wrong, b is wrong, c is right, c is wrong because its speed has to be what, like this. So d, because it has to look like this one. Good. That takes us to problem number 13. Problem number 13 tells us if you have two marble, right? If you have two marble, one over here, right? Okay. All right. One over here, one over here. This one comes, this marble comes with this, this one comes, you just drop them, right? So Vx is 0. This one rolls. This one rolls and drops. This one, let's say Vx is 10. Okay, which one will touch the ground faster? Well, they both touch the ground at the same time. Vx doesn't matter when it comes to, so T only influenced by Vy. T only influenced by Vy, not the Vx, not the Vx. Okay, T never influenced by the time it takes for an object to touch the ground. Never depend on Vx, is only depend on Vy. So of course, ball A, he is the tabletop at the same time as ball B. Okay, that takes us problem number 14. Okay, we are more than halfway, so that's good news. Which graph represents the relationship between acceleration of falling free near the surface of the earth? So acceleration, if you drop again, if you drop, acceleration can never be quadratic. Acceleration never can be linear, diagonal. So acceleration has two options. Acceleration can be only twofold. Acceleration can be like this, or acceleration can be like this. Or maybe acceleration can also be like this, right? Acceleration has only three options. That's it. Acceleration is always constant. Is this constant? Yes. Acceleration is always constant. Is this constant? Yes. Acceleration is always constant. Is this constant? Yes. Acceleration is always constant. Okay. The physics equations we use, we are assumed that acceleration is constant. So we cannot use them if acceleration is constant. These are the example when acceleration is constant. Is this acceleration is constant? No. Is this acceleration constant? No. Is this acceleration is constant? No. This acceleration is constant. Very nice. That takes us to problem number 15. Good. Again, this is the same problem we did it. A stone drop from a bridge 45 meter above the ground. So 45 meters takes 3 seconds. How do you know? D is equal to T is equal to approximately how many seconds? T is equal to square root of 2D over 10, right? So you have 2D 2 times it says 45, right? 45 over 10, right? So T is equal to 90 divided by 10. So T is equal to square root of 9, which is what? 3. Okay, so it takes 3 seconds. Pretty straightforward. An object, if I drop it from, if this one, if I drop it, right, at 1 second it can fall 5 meter, at 2 seconds it can fall 20 meter, at 3 seconds it can fall 45, at 4 seconds it can fall 80, and so on. Okay, good. That takes us problem number 16. Okay, whose graph best represent the motion of an object traveling constant positive velocity? Constant positive velocity. Is this constant positive velocity? Okay, let's draw velocity. So A, we're going to draw 4. A, velocity versus time. B, velocity versus time. C, velocity versus time. And D, velocity versus time. Okay, now A, we're going to convert this one velocity versus time. B, we're going to convert this one velocity versus time. C, we're going to convert this one to velocity versus time. D, we're going to convert this one to velocity versus time. So this one is velocity, loss of velocity, and zero velocity, almost zero velocity. So loss of velocity, almost zero velocity. Okay, good. So okay, so it says that whose graph best represent the motion of an object traveling at constant positive? Is this constant positive? This is constant but negative. Is this constant? No, this is not constant. Is this constant? No, this is not constant. Is this constant? Yes. Is this positive? Yes. So A. That takes us to 17. Okay, now whose graph represent the motion of an object traveling with a positive velocity and negative acceleration? Okay, again we're gonna draw the graph. A, B, C, and D. Okay, these are all velocity graph, right? These are VT, 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 and VT. Okay, this one would look like what? This one is position versus time. So then velocity versus time would look like this. B, this one would look like this. So this one is here you have a loss of velocity, here you have a zero velocity. So B, here you have a loss of velocity, here you have a zero velocity. Okay, this one would be negative, so negative, and this one would be here you have okay, so this one you have so if you put a tangent line, so the velocity would be 0 over here, and then and velocity would be increasing. So this would look like this. Okay, good. So now if we see that a positive velocity and negative acceleration, is this positive velocity? let's see, positive velocity and negative acceleration. Is this positive velocity? Yes. Velocity is positive, yes, but acceleration is 0. No. Is this positive velocity? No. Is this positive velocity? No. Is this positive velocity? Yes. Is this negative acceleration? Yes. Okay, so it's B. How it is negative acceleration? We can draw AT graph. AT graph. AT graph would be the slope of this one. Okay. Okay. All right. Very nice. So velocity is positive, acceleration is negative. Right? Good. And one example of this one would be what? When you kick a soccer ball. When you kick a soccer ball, then from location A to B, the velocity is positive and acceleration is negative. Okay, good. And that takes us problem number 18. Okay, so you're going to quickly go to problem 18. Okay, good. 18. A car moves with constant non-zero acceleration along a straight line whose graph best represents the relationship between distance and time. Acceleration is not zero, right? Acceleration is not zero, but it's constant. Okay, if you draw velocity, acceleration has to be non-zero, whose graph represents the relationship between distance and time. Okay, a car travels with constant non-zero acceleration along a straight line. Okay, so this one acceleration would be, for this one, let's see, let's construct it over here. Okay, this is velocity, this is acceleration. Velocity would be this, and acceleration is this. Let's see whether they're satisfied. A car with constant non-zero acceleration along a straight line, whose graph best represent the relationship between distance, the graph travel. Okay, so that's it. That constant non-zero is this. This is not zero, right? This is not zero. This is something. This is 1 or 2 or 3. So constant non-zero acceleration. All right, that's it. Here acceleration is 0. Here acceleration is 0. Okay, so this seems to be only the choice. You can also, okay, so this acceleration is 0. This acceleration is 0, right? Okay, and this distance versus time, which should look like an acceleration versus time. Distance versus time should look like this, right? And acceleration versus time should look like this, right? Acceleration versus time and distance. This one is a straight line. Mr. Bari moving from A to B, right, in a straight line, and he's accelerating. And this one is not going to be a straight line. This is kicking a soccer ball, right? So kicking a soccer ball. So 18 is A, therefore. And B and D are not even an option. Okay. All right, 19. Okay, whose pair of graphs represent the same motion of an object, right? Okay, now if the displacement is a quadratic, the velocity has to be linear. So this is too good. If the displacement is diagonal, velocity cannot be diagonal. If the displacement is diagonal, velocity, if the displacement is diagonal, velocity can be horizontal, but this is positive slope. So no, this is not good. If the displacement is quadratic, velocity cannot be horizontal. This one should look like this. So that's not good. So that therefore is A. That takes us to problem number 20. When we do problem 20, during which interval the car moving with constant speed, right? So this is only the constant speed. Why is that? Because the displacement time graph below represents the motion of a car initially moving forward. So this one is moving forward. This one is moving forward. This is not velocity constant. This is acceleration is greater than 0, right? This is velocity is constant because acceleration is 0. This is velocity is 0, right? Object is not moving forward. This is velocity is 0. This is acceleration is 0, right? And velocity is constant, but this is velocity is constant, but this is not moving forward. This is moving backward. So this is the only choice, B to C. All right, that takes us to 21. So we want to find the displacement. Displacement is the shortest distance between 2 points. So we want to find the shortest distance between 2 points. So what is the distance between this of the red line? The red line would be these two green line. That would be 0.8 and that would be 0.6. 0.8 plus 0.6 is 1.4. 1.4 to the south, because this is south, the arrow is to the south, so 1.4 to the south. And that takes us to problem number 22. Problem 22 would be what is the maximum speed reached by object during 10 second maximum speed during 10 seconds. The maximum speed would be 25. This is maximum speed, right? This is maximum. This is not maximum speed. This is not maximum. Nothing is maximum. This is maximum speed, and maximum speed is at 25. You see that at 25. Good. This is that takes us to problem number 23. Problem 23 is pretty simple. What is the magnitude of the acceleration? Again, acceleration is Vf, which is this one, minus Vi, which is this one, divided by Tf, which is this one, minus Ti, which is this one. Okay, so let's do it then. This one is 40 minus this one is minus 10. Okay, this one is Tf is 5 minus 0. So you have 50 over 5, 50 over 5, which is 10. Acceleration is 10. 50 over 5, which is acceleration is 10. Okay, excellent. Mr. Body drops a ball. Okay. So Mr. Body drops a ball 10 degree ramp. So is 10 degree, right? 10 degree angle, but we don't need to find the angle. So I'm gonna take the marble, right? And I'm gonna roll this marble like this, right? It rolls for how long? 2 seconds. And it rolls for how long? 5 seconds, right? Okay. And the inclined plane is 2 meters. So then we know that acceleration is constant. So if we find acceleration between, so it is rolling here. So this is 0 second to 5 second, right? It rolls for 2 meters. So this is 2 meters. This is the marble, right? This is the marble. Okay, so we know that acceleration is 2d over t square, right? So then 2 times d is how much? D is 2, and t square is given, right? At the end of 2 seconds. At the end of 2 seconds is 2 square, right? And that gonna give us at the end of 2 seconds. So ramp is 5 seconds. Okay, so at the end of 2 seconds, the ramp is 5 seconds. So I have to go 5 square. So 4 over 5, 25. 4 divided by 25 is how much? 4 divided by 25, and that would be 0.16. 0.16. Okay, so 0.16, yeah. So that's D. Last one. Wow, finally we are on the last one. We're tired. Whose graph best represents the object in equilibrium? Equilibrium means acceleration is 0. Good. Okay, so the distance, is the acceleration is 0 over here? No. How do we know? Okay, let's draw it. This is Vt. Vt is like this. Okay, then At should be like this. Okay, so this is acceleration is not 0. Acceleration is more than 0. So this is not good. All right, velocity versus time. Okay, what is the acceleration over here? Let's see. Acceleration is this is At. So acceleration must be this one. So acceleration is less than 0. So this is no good. Momentum, on your reference table, what do you know about the momentum? Momentum is mb, right? Momentum is mb, and then t. All right. So so forget about the mass. If the velocity versus time is diagonal, the acceleration has to be, so I'm sorry, this is mb. Then if velocity versus time is diagonal, acceleration has to be this one. So this is also no good. Kinetic energy on your reference table, page number 6, I ask you to read page number 6. Kinetic energy is half mv squared. Okay, and oh, sorry, kinetic energy is half mv squared. So velocity versus time, if velocity versus time is, if the velocity versus time is a horizontal line, acceleration versus time has to be 0, right? So this one is in equilibrium. Okay, so that was exam number 5. I'm going to give you exam 6. It's going to be short response. Please make sure you understand that when you do exam 6, yeah, I'm going to give you 13 problem directly come from the question bank, 69 questions that I posted long time ago. Make sure you print them, solve every single problem over the weekend as many times as possible, unless you until you get 100. And then the other thing I wanted to tell you that, what was that? Okay, yeah, 813 that I posted, that is the reaction time of a distracted and undistracted Isaac. So 2 questions going to come from there. So there would be 15 questions, November 10, your exam number 6. And that would be the last exam of MP1, okay? But the main thing of MP1 is the presentation project. Make sure, please make sure you are not doing this project for me. You're doing it for you, right? So long run, think about the long run. Okay, make the project as good as possible. Look forward to see you Monday. Everybody have a wonderful weekend. Bye.